Hello, dear audience, those who joined this webcast. My name is Alla Kravets, and I'd like to talk to you about AI and its applications for creativity and technical invention. First of all, let me introduce myself. I'm the lead for the cyber-physical systems in Volgograd State University and the professor of CAD and RD department in Volga Technical University. An expert for a number of programs and funds. This year I was lucky to join the World AI and Data Challenge event. That is very different from other events because we are engaged in coordinating the project. And I work with a lot of interesting magazines like Springer's Creativity and Intelligent Technologies, and we carry conduct a conference once biannually to talk about the data science and published by Springer. So, moving to the topic of my presentation, I would like to discuss the discussion between the Dell Spooner and a robot, because he is an imitation of life. Can a robot write a symphony or create a canvas into a beautiful masterpiece? Which was replied by the robot very logically, like, can you? Most people, just like robots, cannot create not even a masterpiece, but just, draw a straight line. But they are still people. Since then, many years have passed, but the question is still true. Can the computational creativity be effectively applied to image generation, like in GANs or neural nets, musical tracks, texts. And of course, if you ask someone about the creativity, pretty much anyone will be called a creative person if you dance or photo or draw, whatever. But it's less and less that we think that the engineer creating those new things is a creative person. Even though the engineers create those things that we use every day. And besides music and other graphical images, we get huge amount of new information every minute. Most of the time this is text or images generated by the user, so original content, user-generated content, and soundtracks, sound messages in different messengers. So what should we do with this huge amount of data, especially if we would like to apply AI in a useful way? First of all, we need to support invention. In Russia, we had a number of research projects to analyze. Mostly it's the theory for creative invention tasks. And some strange things represented on the slide, starting from accounting in creativity or chewing your pen, constantly practicing it and becoming an inventor. There are, of course, mentions of real projects to support invention, and mostly those are information support systems. Some would focus on developing creativity and engineering focus. So what do we do? The first step we made, and quite a successful one, was a collaboration with on statistical and semantical methods for text processing. By text, we meant a big array of patent texts that contained more than 80 million documents, and we approached it with known methods of big data processing and text analysis that we applied many times in social media, analyzing comments, analyzing emotions, and other things. So, in the end, we've came up with the multidimensional patent space concept, implemented as an intellectual system with a patent designer, and it was an order by a project by Worldwide IP Organization, and it was presented on their Worldwide Congress. So what did we propose? We proposed to create a network-like structure where every node would be a statistical or semantic profile of the patent and the metadata about the source. So the connections between the sources were the statistical measure of proximity, and then we will have more details about this in the next presentation, but what we achieved is we have now inventor's personal space where after uploading the patent you get the analogs in Russian and English. We have a bilingual system and shows the proximity of the similar patents. We also saw an issue here because besides patents, besides the text in patents, we have objects that cannot be classified as text, like tables or genetical sequences and other things like graphs, pictures, and formulas. Even the source code is not a text itself, and it's hard to be compared. Thus, we got an idea to implement a holistic comprehension of the computational system as a document based on analysis of not only the text but also the graphics. And by the graphics we mean the perspective that is discussed a lot in the patent community, and it says that together with the patent we will be able to provide 3D models, audio and video information. So accordingly, we've used the deep neural networks capabilities. We've used the seance neural networks GAN to ensure we create a training set. Even with the engineering images, there's not enough of them to create a decent data set, so we had to synthesize the data set to train our models. And now we can classify and compare the images, because now they create they contain some new data, new elements. So, after understanding that invention support or expert work support is an interesting thing, it's a trivial stuff. To understand the proximity of texts, for example, there's a lot of solutions, like anti-plagiarism solution. So to be successful in the inventions, you need to understand how trendy you are, how you understand the how well you understand the technology, whether they are really on the cutting edge of technology, because you can keep researching the windmills, but they will probably not give you a wind turbine to produce electricity. So the first thing we asked our researchers was, how well can we identify the new technologies? How well can we understand their value and potential? And we started with the new class of systems called cyber-physical systems. And we've trained the classifier that had 4 classes of patents: the machines, physics, electricity. We had to reduce the dimensions and visualize it in a comprehensive way, so we had to run it through an SME algorithm, and we got an interesting picture that enables you to get a new class out of different patent classes that is identified by us as a cyber-physical system. So here it is, depicted by the rectangle, and we trained the model based on this data set, and on the test data set we got the result that is very good. We can identify this class of technologies very well. So after that, we started to work with identifying the technological trends, and this is why this area is full of articles and publications, and the library is growing, and we analyzed the bibliometry here. So we decided to come up with AI tools and solutions. So, to begin with, we were identifying the keywords, not the ones that usually the authors mean as keywords. Of course, we enriched the set of keywords, and after applying the algorithm for machine learning, we were able to see top 30 keywords trained on the model during 2005 to 2016. So after that, we've decided how well can we predict the keywords that will be trendy during the next 3 years. So we took the documents from the Web of Science and Archive.org preprint collection, and had a look of what out of the top 30 words that are here will be in the growing trend in 2017-2018. So as you see, the result is very good. 22 out of 30 keywords have shown a growing trend. And thus we have decided that the algorithm we've proposed, based on the direct quotation network, so the metrics would allow to measure the importance of each and every article. taking top 50 most influential articles, and it was relative to the time of the publication. So it allowed us to take into account the possibility of quoting. Sometimes it's slower because people did not have time to just read and use it, so we had to add some weighted coefficient to account for time. And after that, we decided that it's good time for us to start predicting the technological trends by analyzing the big grams, the combinations of two words. And we see here that the main trend is the continuation of machine learning and reinforced learning to be growing fast, and the technologies, of course, are growing. So if we take supervised learning and understand this term is so important, then clearly the technology is being used with this training method will be growing and developing, like intellectual games, multi-agent systems that connected to supervised learning, so and so forth. Some trends are going down, like big data is getting less popular and less used in the publications. So I think that the big scientific life will also lose big data at some point in time. The trigram analysis have shown that the neural nets are on a growing trend, and besides that, convolutional is going down. Recurrent neural nets are growing, and their usage and application is consequently growing. And convolutional neural nets, GAN networks that we used recently are getting less and less popular. So our model has shown the reduction of in the popularity of this term. Also, we have less and less natural language processing being mentioned, and we can of course discuss those predictions in much detail, but supporting the technical inventions is a trend, obviously, and it plays a huge role. So I hope that the role of the AI in our country, not only in the regions, but in the country in general, will allow for this picture provided here to the regions to predict us which of the regions will benefit the most from the AI, and I hope we will not be a gray area on the future map that is presented here. The hope here is mostly on our children and grandchildren sometimes, so that they choose technical creative areas, engineering namely, to apply their energy and talent. With that, thank you. Thanks, Alla, and a number of questions to you. So, first of all, probably you've answered it, but I'd like to somehow dive deeper. So, creativity means creating something new, and is it available to the AI, or the AI can only create something that is that we've trained it? Well, patent trolling was emitted from my work, and now they use for the generation of different technical solutions. They use neural networks and AI. So they just take a patent and replace some very minor thing and still get a patent. So in the East, this is not something that happens very often. Usually people patent only things that have commercial viability, and in Russia more and more of them are written just as a KPI for the university and scientific institutions. So creating those new solutions is pretty much impossible without those intellectual systems. You can even look at WIPO site to see that all big companies invest a lot in R&D, not only for the final product, but also for the patents, the research, generation, and AI. Obviously, the system can generate new things for you, same as it generates a picture based on the music. But the main issue will be setting the goal. Because the person cannot often explain what they want, what is the advantage they want to get, stuff like that. So generating a language, creating a language that would allow the person to explain to the machine what they want to get, so that the machine can make this decision. That is something of interest. And explanatory neural nets are thus developing very fast. Thank you. So when people get creative, create something new, they use brainstorm. Is there a possibility that the AI will brainstorm together with the person? Well, brainstorm has a method for creating new things. It's been often used. It's not always effective, like for technical tasks it's mostly ineffective. People using the information that they have in their heads are somehow pouring out that information, and it's usually less info than is available to the AI system. So when we use generative networks and the next network chooses the best one, well, in reality this is direct analog to what we do in invention. So, yeah, robots will definitely be interesting to talk to. Okay, so, yeah, it sounds like we will be happy to enjoy that future, and a very good proposal was not to be a gray area on our creativity map. So, thank you, Alla, thank you indeed, and bye-bye.